This is lesson 9.1, solve quadratic equations using the square root property. The learning objectives are to solve quadratic equations of this form, a times x squared equals k, using the square root property, and then solve quadratic equations of this form, a times x minus h squared equals k, using the square root property again. Great. So in the past, you have learned how to solve quadratic equations by factoring. So if we encounter a quadratic equation, we set it equal to 0, and then we factor the quadratic to see if it's factorable and see if we can solve that way. If it's not factorable, then we try other methods, and this is another method, the square root property. Great. So the square root property says if x squared equals k, then x equals the square root of k, or x equals the negative square root of k, or it equals both the positive and the negative square root of k. So these are the three possible solutions. Now, all possible solutions are this version of it, okay? So we need to, when we square root both sides of an equation, include a plus or minus symbol. I'll show you many examples of this in this lesson. Now, here's how to solve a quadratic equation using this square root property that we now know. Step 1, isolate the quadratic term and make its coefficient 1. So we want to get the quadratic term by itself. Now, little reminder for you, quadratic means the variable squared, okay? So just get this out of the way. If the variable is raised to the second power, that's what a quadratic is, okay? So we want to isolate the term that is the quadratic term, making its coefficient 1. Now, step 2, use the square root property that we just learned above. And step 3, simplify the radical. Step 4, check the solutions. Great. Well, let's just jump into some examples and make sense of this. So example 9.1 says to solve x squared minus 50 equals 0. So my first objective, step 1, isolate the quadratic term, meaning I should get this constant of positive, negative 50 to the other side by adding 50, right? So I'm adding 50 to the other side of the equation. And now I have isolated the quadratic term x squared. It's isolated, okay? At this point, to undo squaring, we square root. Great, so I'm going to square root both sides of this resulting equation. But when I do it, I need to use the square root property, which says that the solution could be the positive square root of 50 or the negative square root of 50. Okay, so I'm including both possible solutions for the variable x when I include the plus or minus symbol. When you square root both sides of an equation, the side that doesn't have the variable gets the plus or minus symbol, always. And you'll see that over and over again in this lesson. So I have x equals plus or minus the square root of 50. But the square root of 50 simplifies, right? We can use the product rule of radicals to say, like the square root of 50, that's just the square root of 25 times the square root of 2, right? So we're using the product rule of radicals to separate a single radical into two radicals with a perfect square under one and the leftovers under the other thing, okay? So because the square root of 50 equals the square root of 25 times the square root of 2, well, we can turn the square root of 50 into 5 times the square root of 2. And we also had the plus or minus symbol from the square root property here. And this is the final solution. So x equals two things. This plus and minus symbol stacked on top of each other mean, well, x equals positive 5 root 2 and x equals negative 5 root 2. If it helps your brain, you could write your solutions with a comma between them. So you could write it as negative 5 root 2 and positive 5 root 2. So some students prefer to see their solution written like this. In fact, sometimes in your homework assignment, you'll be asked to separate your solutions with commas, okay? And, maybe sometimes it'll allow you for using the plus or minus symbol stacked on top of each other. Let's try another example. This is 9.2. When I see 3 times x squared equals 108, my goal first is to isolate the quadratic term. That's x squared. And so the first objective I have is to divide 3 from the left side to the right side, because now I have isolated the variable squared, the quadratic term. And 108 divided by 3 Wow, that comes out to 36. And then I get really excited about the number 36 because I realize I'm about to square root both sides of this equation, and 36 is a perfect square. And so my solution is x equals plus or minus 6. Another way to write that solution, you could separate it with a comma. You could write x equals negative 6 and x equals positive 6. But you have to get the two solutions, right? When you square root both sides of an equation, the side without the variable gets the plus or minus symbol. That's what happens. Let's go on to example 9.3. We're going to try another one. X squared plus 72 equals 0. Now, my goal is to get the quadratic term by itself. So I subtract 72 from left to right. And now I get, well, x squared, the quadratic term all by itself. So there's the quadratic term all by itself. And it equals negative 72. At this point, I'm going to square root both sides of this equation. And when I do it, I always include the plus or minus symbol of the square root property. I just applied the square root property. When I square root both sides of an equation, I need to include that plus or minus symbol stacked on top of each other. And the square root of x squared is just x, and that equals plus or minus the square root of negative 72. Now, when you have a negative sign under an even index root, that is imaginary. Okay, so the first thing we're going to do is we're going to write it as the square root of positive 72 and then multiply I after that square root of 72. Okay, so how do you get rid of this negative under an even radical? Well, you can make this positive 72 if you multiply I after it. And let's define I on the side here. So everybody, I equals the square root of negative 1. I is the imaginary number, okay? And sometimes our solutions are imaginary. That's when we have negative numbers under a square root or a fourth root, any even root, okay? That's what happens. And now we can take this square root of 72 and we can simplify it. All right, so I have x equals plus or minus, and I have a good square root and the leftover square root, and then still that multiplication of I afterwards. And 72 is a multiple of a perfect square, and that perfect square is 36. So I'm going to break 72 into 36 and 2, right? 36 is the perfect square, 2 is the leftovers. And so to finish my final answer, I will say x equals plus or minus 6 root 2 times I. Okay, so that's everything right there. That's x equals plus or minus, right? The square root of 36, which is 6, times the square root of 2 times I. Now, why is there I one last time? There was a negative under an even radical. That's why there is an I. It's an imaginary solution. Okay, that's what it just ended up being called in math. Now, you could separate your answers. You could say, hey, x is negative 6 root 2 times I, and it's also positive 6 root 2 times I. Now, never let your I go under the radical. That imaginary number I, it's after the radical. You could also place it before the radical. Some teachers put it before the radical because they don't trust their students not to put it under the radical when they put it after. So wherever you decide to place it, it doesn't matter because multiplication is commutative, meaning order of multiplication doesn't matter for these cases. Example 9.4, solve 2/3 u squared plus 5 equals 17. And so my goal is to isolate the variable that is squared. And so first I will subtract 5 from left to right. I'll write my result. I have 2/3 u squared equals 17 minus 5, which is 12. At this point, I would think to divide by the fraction 2/3, right? But please remember, dividing by a fraction is the same thing as multiplying by its reciprocal, and sometimes that's much easier for your brain to think about. So I'm going to, instead of dividing by 2/3, I'm going to multiply by its reciprocal on both sides, like this. Okay, because when you multiply the reciprocal of a fraction with that fraction, well, they fight and die. Look, 3 cancels 3, 2 cancels 2, and all we now have is u squared, the variable squared. That's what we want. That's the quadratic term that's isolated now. And then we take 12 and we multiply it by 3 halves. Now 12 divided by 2 is 6, and 6 times 3 is 18. That's why I get 18 right here. At this point, I apply the square root principle. And I always include a plus or minus symbol when I square root both sides of an equation. And that's on the side that doesn't have the variable that I put that plus or minus sign. And now I have solved for u. It equals plus or minus the square root of 18. But remember, we can simplify radicals using the product property of radicals. 18 breaks down into a perfect square of 9 multiplied by 2. Okay, so I'm going to separate the single root into 2 roots. The first root has the perfect square. The second root has the leftovers, just like we've been saying over and over again. And now the square root of 9 is 3, and that's multiplied with the square root of 2. And I have that plus and minus symbol showing 2 solutions, right? I have the positive 3 root 2 and negative 3 root 2 as my solutions. Hey, for good measure, I'll show it to you. This is 2 solutions, negative 3 root 2 and positive 3 root 2, and I've separated those 2 solutions with a comma. You know, quadratic equations, they have 2 solutions for the variable oftentimes. The majority of the time, you have 2 solutions, right? Here we had 2 solutions, this one and this one. Here we had 2 solutions, this one and this one, this one and this one, this one and this one. Great. So quadratic equations have 2 solutions. If you don't find 2 solutions, you should go back and think, why didn't I have 2 solutions? Let's go ahead and solve example 9.5. We have 2x squared minus 8 equals 41. My goal is to isolate the term that is squared, the quadratic term, just this x squared. And so first I'll add 8. Great. And so I get 2x squared equals 49. And now I'm going to divide by 2. And you'll see I've gotten my quadratic term all by itself. It equals 49 halves. I'll keep it that way. I'll keep it looking like a fraction, 49 halves. Great. Now at this point, I use the square root principle. I square root both sides of the equation, and I put a plus and minus on the side that doesn't have the variable. There we go. Sweet. Let me clean this up over here on the left side. So, you know, the square root of x squared is just x. And that equals the square root of 49 over 2. So remember that we could use the quotient rule of radicals, meaning we can separate the single square root into 2 square roots on top and bottom of this fraction. So I could have this plus or minus and then the square root of 49 divided by the square root of 2, like that. All right, well, this equals plus or minus, well, the square root of 49 is 7, right? The square root of 49, it's a perfect square, 7. Okay, and then I have this square root of 2. And in our chapter 8 discussions, we talked about rationalizing a denominator that has a radical in it. So here I have a radical in my denominator. I'm going to rationalize it by multiplying by that radical divided by itself. Because when you take anything and divide it by itself, it's really just 1. Multiplying by 1 keeps this thing really the same. But what we're doing is we're getting rid of this radical in the denominator because it's an irrational number, and we never like to have irrational numbers in our denominator. And so my final answer is plus or minus 7 root 2 over 2. Okay, that's what x is equal to. This is 2 solutions, right? So this is both 7 root 2 over 2 and negative 7 root 2 over 2. Here, I'll write out the answers over here so you see both of them clearly, right? I've got x equals negative 7 root 2 over 2. That's my first solution. And then 7 root 2 over 2 is my second solution. Great. Let's proceed forward. Now, sometimes we have to solve quadratic equations of the form a times x minus h squared equals k using the same square root property we've been discussing. And so I'm going to talk you through various examples of doing this. I do multiple examples just to start to get you comfortable with it. All right, so here I'm going to solve 4 times y minus 7 squared equals 48. The goal is to isolate the quadratic term. In this case, the thing that's squared is y minus 7. So I want to isolate this y minus 7 squared. Therefore, the first thing I'm going to do is divide both sides by 4, right? I'm dividing both sides by 4 to get that thing out of the way. Now I have the quadratic term, right? That thing that's being squared. And 48 divided by 4 simplifies to 12. Now that I isolated the thing that is squared, I apply the square root principle, square rooting both sides of the equation, but I always include a plus or minus sign on the side that doesn't have the variable. Great. Now the square root and the square here cancel each other, and I'm left with just the y minus 7. And it equals plus or minus the square root of 12. Let's see if the square root of 12 simplifies. I can think of a perfect square that 12 is a multiple of, and that perfect square is 4. And then the leftovers is 3. So I'm using the product property of radicals to break the single radical into two radicals, and the square root of 4 is 2. Okay, so I can replace the square root of 4 with 2. Cleaning this up a little bit, I get 2 root 3. There we go. Next, I haven't gotten the variable alone. I haven't solved entirely for the variable y. So next I'm going to add 7 from the left side to the right side. Here I go. I'm adding 7 from left to right. And I write my final answer as y equals 7 plus or minus 2 root 3. This is my final solution. Okay? Now you're going to ask, can't you just add these together? And the answer is no. This is a rational number. This is an irrational number, and they can't be combined together. Okay, so they're not like terms. This one has a radical, this one doesn't. They're not like radicals. You're thinking about that kind of stuff. Now, you can report your answer as two separate solutions. If you don't want that plus or minus symbol, you could do each one separately. So there's the version 7 minus 2 root 3. That's the first answer. And the second answer is 7 plus 2 root 3. Second answer. Great. So this is a way you can report your answer, separating the two solutions with a comma. Okay, so two different ways to report the same solution, there and there. Let's try this again. So example 9.7 says solve x minus 1/3 squared equals 5/9. Okay, so I'll jump in here, and I already have the the quadratic term right here, right? The thing that is squared all by itself. There's nothing outside, there's nothing added or subtracting, yeah? So I'm going to go straight to using the square root principle here. Rewriting this really fast. I'm going to take the square root of both sides to undo the squaring. And I apply the plus or minus symbol, of course, as always. And the square and the square root fight and die. And I get x minus 1/3 equals plus or minus the square root of 5/9, like that. Now, the square root of 5/9, I could use the quotient property because here I have a fraction with a single square root. So what I could do is I could write this as 2 square roots with the numerator in the first one and the denominator in the second one. So I just used the quotient property of radicals. And why would I do that? Because in this case, I see this square root of 9 in the denominator, and the square root of 9 is 3. 9 is a perfect square of 3, and so that makes sense. Next, I'm going to add, to solve for the variable x, which is my entire goal, I'm going to add 1/3 from the left side to the right side. Okay, so I'm adding 1/3 from left to right, and I'm going to report my answer as x equals, right? I got my variable x all alone. It equals, well, let's write 1/3 plus or minus the square root of 5/3. So this is the solution. Some people like to, since they see the same denominator for both fractions, they'll combine the two fractions into a single fraction. And so the common denominator of 3 is written here, and then I get 1 plus or minus the square root of 5 in the numerator, like this. There you go. So you could report your answer with two separate fractions, like this, or one single fraction, like this, or you could separate your two solutions, right? You could write your two separated solutions as 1 plus or let's put minus first, it's a good measure. 1 minus the square root of 5 over 3, comma, 1 plus the square root of 5 over 3. There we go. So different ways that you could report your answer, and I like showing all of them. Moving on to example 9.8. It says solve this one. And I have 2 times x minus 2 squared plus 3 equals 57. Now I want to isolate the quadratic term, this x minus 2 squared. So let's do the easy stuff first. And we'll subtract 3 from left to right. I'll write the result here. 57 minus 3 is 54. Now I'm going to divide by 2, right? That way I can cancel this stuff. And I end up with the quadratic term isolated. X minus 2 squared equals 54 divided by 2, which is 27. Let me give myself a little space because I'm about to square root both sides. And when I do that, I never forget the plus or minus symbol. Okay, so I have just made it so that I've undone the squaring, right, by square rooting. So the square root and the square, they fight and die, and I get x minus 2 equals plus or minus the square root of 27. Now, the square root of 27 simplifies because 27 is a multiple of a perfect square, 9. And so I can turn the square root of 27 into the square root of 9 times the square root of 3. And the square root of 9 is 3. So I'm going to erase the square root of 9 and turn it into 3 and multiply that by the square root of 3. And there I've simplified it all the way. Now, my entire goal is to solve for the variable x, which means I need to add 2 from the left side to the right side. Here I go. Adding 2 from left to right. I can now write my final solution as x equals 2 plus or minus 3 root 3. There's the solution. Of course, we can separate our answers with a comma if we like. So x equals 2 minus 3 root 3, comma, 2 plus 3 root 3. Okay, so both of these are the solution. One is with a stacked plus or minus sign. One is separating the solutions with a comma. And here's 9.9. Example 9.9 says solve 2x minus 3 squared equals negative 12. And I notice that the quadratic term is already isolated. I have no extra things to do, right? The stuff's in parentheses and it's squared. And so now I can apply the square root principle. I'll just rewrite this really fast. I have 2x minus 3 squared equals negative 12. And what I'm going to do is square root both sides right away. And of course, I would never forget the plus or minus symbol because that's the whole idea of this lesson. It's the square root property that we're using. Great. And so the square and the square root fight and die. I get 2x minus 3 equals plus or minus. I get to this point and I say the square root of negative 12. There's a negative under an even radical, so I need to apply I. Now remember, I equals the square root of negative 1. That's the definition of I. I is the square root of negative 1. Okay, and so really negative 12 is negative 1 times 12, and the square root of negative 1 is I. So I can get rid of this negative and turn 12 into a positive by multiplying I after that radical. Okay, just go from here to here, make that negative disappear by multiplying I after the radical. Now the square root of 12, 12 is a multiple of a perfect square of 4. So I can turn the square root of 12 into the square root of 4 times the square root of 3, because 4 times 3 is 12. Anyways, I'll write it down below. 2x minus 3 equals plus or minus the square root of 4 times the square root of 3 times I. And the square root of 4 is 2, right? You know that. 2 squared is 4, so the square root of 4 is 2. So let's replace the square root of 4 with 2. Great. The last things to do, well, my entire goal is to solve for x. So I'm going to do two operations. I'm going to add 3 to the other side, and then I'm going to divide by 2, and I'll have solved for x. Watch me do it. I have addition of 3. Great. And so I get 2x is equal to 3 plus or minus 2 root 3 times I. And now division by 2. There you go. And so my final answer is x equals 3 plus or minus 3 root 2 times I, all divided by 2. Now, you could separate your answers, right? So x equals 3 plus, or I'll do minus first. I'm going to try to stay consistent. I've been doing minus first. 3 minus 3 root 2 times I over 2. That's my first answer. And then the second answer is 3 plus 3 root 2 times I divided by 2. That's my second answer. Okay, so separating your two solutions with a comma would result in this. Awesome. That was example 9.9. And now for the last example of this lesson. Here is example 9.10, and it says to solve this equation, 4n squared plus 4n plus 1 equals 16. Great. And so looking at this, I think, well, this isn't in the same form that the other ones have been in. It's not like the others. Because here we had binomial squared, binomial squared, binomial squared, binomial squared, and this does not have a binomial squared. But what I do notice is this is a perfect square trinomial. Okay, so let's factor this perfect square trinomial. And thinking about it really fast, I'll break it down so you see this. Okay, and I can turn this into what, 2n plus 1 times 2n plus 1. Let's make sure. If I FOIL this, I get 2n times 2n, which is 4n squared, and then 2n times 1, and a 1 times 2n, which makes 4n, and a 1 times 1, which is 1. Great. We just factored this into this. Great. We used our factoring skills back from chapter 6. But we notice that the two binomials are the same. They're the same two binomials, so we can write them as 2n plus 1 squared. Right? Because isn't that the definition of multiplying the same thing by itself? Taking that thing and squaring it? Yeah, that's what it is. And now we see the binomial squared, and now we can use the square root principle that we've been talking about today. So I'm going to square root both sides, including a plus or minus sign, because why would we ever forget that now? And then the square and the square root cancel each other. So I get a 2n plus 1 equals plus or minus. And the square root of 16, well, 16 is a perfect square of 4. So that's plus or minus 4. At this point, my entire goal is to solve for the variable in. So I'm going to subtract 1, and then I'll divide by 2. So you'll see me do it. I subtract 1. Great. And so I get 2n equals negative 1 plus or minus 4. And now I divide by 2. There we go. Great. And so now I get n is equal to. At this point, I say, well, I've got two solutions. I've got the plus version and the minus version, correct? Let's do the minus version first. I'm going to take negative 1, subtract 4. Negative 1 minus 4 is negative 5, and that's divided by 2, right? So division by 2 for the first solution. Now let's do the second version. And we're going to take negative 1 and add 4. That gives me 3 divided by 2. And that's my two solutions. Negative 5 halves and positive 3 halves are the two solutions for n. And now we have gone through 10 examples in this first lesson of chapter 9. And I hope that I have trained you to use the square root property. Okay, the square root property. Include always those plus and minus symbols stacked on top of each other whenever you square root both sides of an equation with an even radical, an even index radical, like a square root, a fourth root, a sixth root. That's when it applies. Not for odd radicals, only even radicals. Thank you so much. Have a great day, and I'll see you in the next one.